Chapter 14, Section 6, in the 8th grade note-taking guide, is entitled Multiplying Binomials Together. So as you know, binomials are two-term polynomials, meaning they're going to be separated by only one, addition or subtraction sign. So the process of multiplying binomials is done by a process known as FOIL. That's the most common. There are some others. I'll show you one of the others that you might have some success with as well. But FOIL is an acronym for the terms used in multiplying two binomials, standing for first, inners, outers, and lasts. The F in FOIL is first, the O in FOIL is outers, the I in FOIL is inners, and the L in FOIL is last. That describes the 4 different multiplications you have to do in order to successfully multiply together two binomials. Now that can actually be a tricky process. So what you will see we will do is we will also introduce this as a table method that does the same multiplications but shows that work in a different order. So let's go ahead and take a look at 1a. We've got the binomial n minus 2 being multiplied with the binomial m minus 8. So the good thing we can do first here is identify our F, the O, the I, and the L, because we need to know what those things are. F stands for the first. So when we're talking about the first, what we mean here is the first term in each binomial. So in this problem, that's the n and the m. All right, and we're going to multiply those together, and that's going to get dragged down into our solution. Then we've got the O. The O stands for the outers, the outside terms in the expression. So that's going to be this n here and the 8 here. They're furthest on the outside of what I've written here. And those are going to get multiplied together and get dragged into the expression. I stands for the inside terms. So that's what's inside our polynomials here, what's inside what we've written here. That's our 2 and our m. And again, we're going to pick the signs in with them. And L stands for the last. That's the last term in each binomial. So that's my 2 and my 8, which are also going to have to get multiplied together, and we'll drag that down into the answer. Now there is potentially some like terms that could be derived then when you multiply all that stuff together, and then you would have to combine those like terms because those are all going to be connected, each term that you figured out, with addition or subtraction. This is one of those sections where it's most helpful to take the time to change subtraction into adding the opposite, because then we know we'll have some negative signs, but everything's going to be hooked together with an addition. So that's exactly what I'm prepared to do here. I'm going to change this into n plus negative 2 being multiplied by m plus negative 8. I changed both of these subtraction signs into adding the opposite, the same way when we learned about subtracting integers, what we would do based on those rules. All right, so F stands for the first. I'm going to multiply the first terms together here. That's my n and my m. Well, that's a nice multiplication, so we just have to put those together, and that's going to give me nm or mn, whatever you want to say. As you can see in their solution, they've written mn. Then I'm going to go grab the O's, the outside terms here. That's my n and my negative 8. Well, I'm going to run those together, and that's going to give me negative 8n. Then I'm going to grab my inside terms, what's inside the expression that's been written here. Well, that's my negative 2 and my m, and I'm going to multiply those together, and that's going to give me negative 2m. And then I'm going to get my last terms, the last term in each binomial, negative 2 and negative 8 combined to make positive 16. So I write plus 16 there. And as you can see, my answer looks a little bit different than the answer that was pre-printed. Again, the reasoning is we got rid of the subtraction so we don't make a sign mistake. Here you can see they wrote minus 8n. Here instead we wrote plus negative 8n. Here they wrote minus 2m. Instead they wrote plus negative 2m. But it's the same thing. You know that 3 minus 4 would be the same as 3 plus negative 4. And that's exactly what they've done. And that's the process known as FOIL. It's me taking every term and multiplying it by every other term. Now you're saying, oh, that's a lot of work. Yes, indeed, it was a lot of work. We do have a potential helper here in the form of a table method.
The table method will still do FOIL for us. It will still do the steps of FOIL, but it does it in a different way. Let's try that in B here. X plus 3 times x plus z. Now, one of the things you would do with the table method, just like when we did FOIL in 1A there, is you would go ahead and change subtraction into adding the opposite. All right? As you can see, these are both addition, though, so we don't have to worry about it. So we're going to go ahead and sketch ourselves a little table here, and you're going to make, kind of like you're making a Punnett square in science, you're going to chop it up into 4 even blocks. Across the top, you want to go ahead and list your one polynomial, x and 3. And down the sides, you want to list your other polynomial, x and z. And as you can see, I'm totally leaving the plus signs out because that's the point of changing subtraction into adding the opposite. I know that when I put all this together, once I've done that step, that I'm just going to stick addition signs in between everything. So as long as you've done that step, you don't have to worry about signs. If you don't do that step, you're going to have quite a mess on your hands when you have to go back and recreate this. Table. Each box is simply the product of what's above it and what's to the left of it. So for instance, this upper left box Here has x above it and x to the left of it. So I'm supposed to multiply together x and x. Well, you know from the product of powers rule, when I multiply together problems with the same base, or multiply together powers with the same base, I add the exponents. That's going to give me x squared. In this box here, I have 3 above it and x to the left of it. So I just run those together, and that's going to give me 3x. In this box here, I have x above it and z to the left of it, so I'm going to combine those, and that's going to give me xz. And in the final lower right box there, I have 3 above it and z to the left of it. I combine those, and that's going to give me 3z. And all I'm going to do now is combine these all with addition signs. So I've got x squared plus xz, which is here, plus 3x, which is here, plus 3z, which is there. And as you can see, my answer from the table method matches exactly what they did in the FOIL process. Again, it doesn't matter which method you like. You can do either one. The solution is the same regardless of what you choose. All right, let's go ahead and take a look at number 2. It says an 8-inch by 10-inch photo has a wooden frame that extends x inches beyond each side. Represent the area of the frame in terms of x. So you've got the whole area of the whole deal, and they want us to just find the area of just the wooden frame. So obviously, if I've got the whole deal, which I can figure out, I'm going to take off the photo, and what's left is going to be the area of the wooden frame piece that goes around the whole picture. So, as you can see, what they've done here is they're saying to find that, I'm going to take 8 plus 2x and multiply it by 10 plus 2x for the total area. Why is this? Well, here they're expressing with the 8 and 10, the length and width of the photo, 8 by 10, as presented to us right here. And then as you can see on each of those, they're adding 2x. Why are they adding 2x? Well, remember, the frame piece has a width of x. And you've got a frame piece on each side. Here's an x, and here's an x. So you're adding 2 x's to the width here, which is 10. And then you're adding an x and an x here on the frame piece to the length, which was 8. So you're adding 2 x's to both the length and the width. That's how I'm going to come up with my total area. That's the multiplying binomials that we're doing here in this section. As you can see, they're subtracting off the area of the photo. That's easy. The photo is 8 by 10, so they're subtracting off 80. What's left is going to be the polynomial expression for the area of the frame piece. So we have to go through the process of foiling this expression, 8 plus 2x times 10 plus 2x. Now the nice thing is that's already been written with all pluses or positives. So if I want to go ahead and FOIL this, I can do the Punnett square looking thing really quick because it's already set up, it's already been changed all to plus for me. So across the top, I'm going to put 8 plus 2x. Again, I don't really need the plus sign because I know when I write my answer, when I made that change, if I have to, everything's going to be connected with addition signs. And down the side, I'm going to put 10 plus 2x.
All right, so this upper left box here is the product of 8 that's above it and 10 to the left of it. 8 times 10 is going to change into 80. This box here has 2x above it and 10 to the left of it. 2x and 10 go together to make 20 x's. This box down here in the lower left has 8 above it and 2x to the left of it. 8 times 2x is going to give me 16 x's. And this bottom right box here has a 2x above it and 2x to the left of it. Now we might actually have to think about that one a little bit. 2x times 2x. Well, 2 times 2 is going to give me 4. And x times x, using the product of powers rule, says I'm going to add the exponents together. Well, since these are both 1s, those combine to give me an x squared. So 2x and 2x goes together to make 4x squared. And as you can see here in this box, or in this line of work rather, all right, what you see there that I just bracketed is the exact same thing that you see in your box. Your 80 being added to your 16x, being added to your 20x, being added to your 4x squared. Now, they've done some simplification here. First off, you've got 16x and 20x in the middle. Those are like terms because they both have regular old x in them. Since they both have regular old x in them, we can combine them based on that fact alone. 16x's and 20x's goes together to make 36x's, which is what you can see they've listed right here. They've got the 4x squared to drag down to the answer. And then as you can see, we've got 80 in here, but then we're subtracting off 80 for the photo here. So of course 80 minus 80 goes away. So that doesn't go into the answer at all because they've wiped each other out. So 36x plus 4x squared is the polynomial expression that represents the area of the frame. And you can write it the other way. It would have the exact same meaning, 4x squared plus 36x. Now in number 3 and number 4, it doesn't maybe look like the other questions we've done. So maybe you're saying, well, maybe we're about to do something different. And I'm about to tell you, no, we're not doing something different. What it is they've given you a binomial, but then they've said square the binomial. Well, if we're squaring a binomial, that means we're taking the binomial and multiplying it by itself. And if we're multiplying the binomial by itself, that's how we could be multiplying binomials, because it's going to be the binomial times itself, binomial times its own binomial. So, let's do that here in 3a. X plus 6 is being squared. Well, that's really the same thing as x plus 6 times x plus 6. So I want to go ahead and FOIL x plus 6 times x plus 6. So I'm going to go ahead and make myself a little table to do this here. And again, when I do this here, I'm going to make sure everything's been changed to addition, which they have been. And then I'm going to list one binomial across the top and the other binomial down the side. X plus 6 on the top, x plus 6 on the side. Each box, again, is the product of what's above it and what's to the left of it. And again, this is me doing the actual FOIL method, just not writing out FOIL and me trying to loop things together. A lot of people have more success with this table method because of the organization factor. So, this box here has x above it and x to the left of it. X times x, based on the product of power rules, this is going to give me x squared. This box here has 6 above it and x to the left of it. If I put those together, that's going to give me 6x. This box here has x above it and 6 to the left of it. That's also going to give me 6x. Notice these two happen to be the same. And then this last box here is going to give me 6 above it and 6 to the left of it. 6 times 6 is 36. So we go ahead and combine these with addition signs between everything. X squared plus 6x plus 6x plus 36, which is what you can see they've done right here. And then these middle two terms are like terms because they both have x in them. So we can combine them. So 6x and 6x go together to give me 12 x's. And so my final answer is x squared plus the 12x, the combination of the like terms, plus 36. As we look at 3b there, we've got n minus m and n minus m is being squared here. So we have two subtraction signs when I take n minus m and square it, because that's really n minus m times n minus m. And as you know, the best way to do this is to change this into adding the opposite. So instead of n minus m, I'm going to rewrite this as n plus negative n. N plus negative m. I had to do twice because there's two binomials there. All right, so I'm going to go ahead and make myself a little Punnett square here. And the components of both sides, the top and the left, are going to be n and negative m. Again, I'm not writing the plus sign because once we change it to plus, I don't need it. The whole point of changing it to plus is when I go to write my answer, I know everything's going to be attached with addition signs. If I don't change it to addition, I'm going to have a mess of figuring out what sign goes where and how. All right, so let's start multiplying. This box here has n above it and n to the left of it. N times n is going to give me n squared. This box here has n above it and negative m to the left of it. Well, again, I'm just running those together. That's really easy. Negative nm. Or if you want to write it the other way, negative mn. It's the same thing. This box here in the upper right has negative m above it and n to the left of it. It's the exact same thing as this box, another negative nm. If this box here has negative m above it and negative m to the left of it, well, remember, negative times a negative is a positive, and the m and the m, using the product of powers rule, we add the exponents even though we're multiplying, and that's going to give me m squared. So now I'm going to put all these together, and it's going to look just like what you see over here. You've got n squared plus a negative nm, or you can write minus nm, plus another negative nm, or minus nm, plus m squared. Now these two middle terms happen to be the same here. They are like terms as a result, and since they're like terms, we can combine them. So if I have negative 1 nm, and then I take away another nm, now I have negative 2 nm's, which is what you see in the middle here, which is why it says n squared minus 2 nm's plus the m squared. This guy in the front and this guy in the back didn't change. We combine the two like terms in the middle there, and we're done. All right, so let's go ahead and take a look at the concluding examples here in the Check It Out section. Question number 1 says I'm supposed to take r minus 4 and multiply it by s minus 6. Well, as you can see, once again, as you know from my rules that we've been using here as we've been solving the different questions, we've got two subtraction signs, and that's not going to stand. We've got to change those into adding the opposite here. So that's what I'm prepared to do to start here. I'm prepared to change this into r plus negative 4 times s plus negative 6. So let's go ahead and change this into r plus negative 4 times s plus negative 6. All right, I need to apply FOIL, to multiply together the two binomials. So you can do FOIL like we saw in 1A, where we can identify the first terms and put them together, and then you can identify the outside terms and put them together, and then you can identify the inside terms and put them together, and you can identify the last terms and put them together. Let's go ahead and try that here since we haven't done that in a little while. The first terms here, the first term in each binomial is r and s. So I'm going to multiply together r and s for the first term, and that's just going to give me rs. The o term here, or the o terms rather, the outside terms, or what I have on the outside of what I've written here, that's r and negative 6. When I multiply together r and negative 6, you have negative 6r. I in FOIL stands for the inners, or the inside terms of what I've written here. The inside terms of what I've written here are negative 4 and s. That's going to combine to make negative 4s. And L is the last terms of the polynomial expression, the last term in each binomial. That's negative 4 and negative 6, which is going to give me positive 24. And now it's a matter of me just combining the F, the O, the I, and the L with addition signs between everything. And when I do that, that's going to give me RS plus negative 6R plus negative 4S plus 24. Again, it's just me combining all those with an addition sign. I really don't care which method you use. If you want to go ahead and use the table method, you can use the table method. If you want to go ahead and use FOIL, if that makes more sense to you, then use FOIL. If it's easier for you to do one sometimes and the other times, then do whatever you need to when you need to. It does not matter to me which one you use. I have a feeling that most of you, when it's said and done, will probably end up liking the table method better. FOIL, as you've seen here in 1, is more traditional, but it really does not matter. It's not going to have any negative consequence later on down the line of which you use. Both will help you get the right solution. Number 2, an 18-foot by 32-foot swimming pool has a deck around it that extends X feet beyond each side. Represent the area of the deck around the swimming pool in terms of X. So here's my swimming pool. And my swimming pool is 18 by 32. Okay, so now I have my 18 by 32 swimming pool, and I'm adding the deck around it now. And the deck, no matter where I look at, is going to have a width of X. So it's X tall on either side, it's X wide on either side. So I'm supposed to find the area of just the deck. So this is a lot like the photograph picture we did earlier. I'm going to take the expression for the length times the width of the whole space. Well, if I look going this way, that's 18 and 2 x's. If I look going this way, that's 32 and 2 x's. So to find the area of the whole space, it's 18 plus 2x times 32 plus 2x. And then I'm going to take off the area of the pool, and when I subtract the area of the pool, that's going to give me the area of the deck. So I'm going to subtract off this 18 by 32 pool. All right, so the part you all want to do right away, of course, is the 18 by 32 pool, because that's the least amount of work here that we could possibly have to do. Well, let's find the 18 by 32 pool. The 18 by 32 pool is going to give me an area of 576 that I'm subtracting off. All right, now this mess, though, I'm going to have to FOIL this mess. So I'm probably going to use the table method because, as you can see, it's already beautifully set up with all addition signs for me, so I shouldn't have to work too hard at it. So I'm going to set up my Punnett square here, and I'm going to do 18 plus 2x across the top and 32 plus 2x down the side. And remember, each box is the product of what's above it and what's to the left of it. So top left box has 18 above it and 32 to the left of it. Well, as you know, because we've already done 18 times 32 over here, that's 576. This box here has 18 above it and 2x to the left of it. That's going to give me 36 x's. This box here has 2x above it and 32 to the left of it. That's going to give me 64 x's. And this box here has 2x above it and 2x to the left of it. That's going to give me 4x squared. So let's go ahead and put all that together. We've got 4x squared. I'm putting 4x squared first because I tend to like that standard form or descending order that we've talked about so much lately. Doesn't necessarily have to be done that way, but I just like it. 36x and 64x are like terms, so those are going to combine to give me 100 x's. And then here I've got the 576. And remember, since those are all addition, we connect them all with addition. Well, we can simplify this, and as we can see, this is going to be really nice to simplify, because here at the end I've got 576 minus 576. 576 minus 576 goes down to 0, so that's just going to totally wipe out, and what I'm left with is the polynomial expression 4x squared plus 100x, which is going to be the area of the deck of the pool. All right, so let's go ahead and take a look at the last one here. We're multiplying together r minus 3 and r minus 3. How do I know that? Because it says r minus 3 squared. squared. Squared means multiply it by itself. So this is really r minus 3 times r minus 3. But of course, I'm not going to leave it as minus 3, and you know I won't do that, because we've been trying to change all these into adding to the negative so we can make our lives a lot easier. So instead of me doing r minus 3 times r minus 3, I'm going to rewrite this as r plus negative 3 times r plus negative 3. So let's FOIL this, and we'll FOIL this using the table method. Both sides, top and left, are both going to say r and negative 3. Again, I don't have to write that addition sign in the middle because we know we're going to combine them with addition as long as you've changed it all to addition. So, upper left box has r above it and r to the left of it. Well, the product of powers rule says when we multiply those together, we add the exponents. Since there's no visible exponent, it's like a 1. 1 and 1 go together to make 2. This box here has r above it and negative 3 to the left of it. That's going to combine to give me negative 3 r's. This box here is the exact same thing, negative 3 above it and r to the left of it, negative 3 r's. This last box here has negative 3 above it and negative 3 to the left of it. Well, negative and a negative are going to make a positive. So here I have r squared. And then I have a negative 3r and a negative 3r. Well, those are like terms because they both have regular old r in them, so I can combine them. So that's going to give me negative 6r's. And then I combine this last part into that answer, plus 9. And we end up with r squared plus negative 6r plus 9. Exactly what you see right here is a solution, just changing subtraction into adding the opposite.